This is part 2 of our video, where the directions are to describe the end behavior using limits and then explain your reasoning using the leading term test. For letter B, we're going to go through and take a look at this one. F of x is equal to negative 3x squared plus 2x to the fifth plus x cubed. If you're going to use the leading term test, you need to know which term is the leading term. And again, many times that is the very first term. That's why they call it the leading term. It is the leading term if your equation is in standard form, which means no parentheses, and then your highest power of x would be the first term here. But if you look at this one's not in standard form. We'd have to rearrange these to put it into standard form. The highest power of x, that term has to go first. So our leading term this time is actually here in the middle. This is our leading term. All right, let's take a look at that leading term and describe what's happening in our graph. I am going to make a quick little sketch again. Our leading term is a positive 2x to the fifth. The right side of our graph is either going to go up or down. The number in front tells you whether it goes up or down. The coefficient this time is a positive number, a positive 2. And if the leading term has a positive coefficient, then we know the right side goes up. So again, the middle of this graph is going to kind of bounce up and down, but eventually if you go over to the right far enough, that graph is going to go upward. And again, how I know that is the coefficient here is positive. So the right side of this graph is going to end up going upward eventually, and that's because we have a positive coefficient. What determines what the left side is doing? Again, it's either going to go up or down. The exponent tells you that, and if the exponent's even, then the left and the right sides have to match, and if it's odd, then they have to go the opposite. I know that the right side is going up, and we have an odd exponent here in our leading term, so I know the left side has to do the opposite of the right side. The right side is going up, so the left side of this graph is going to go downward. And I know that that's true because we have an odd exponent. Okay, now that I know the right side goes up and the left side goes down, I am ready to write down the end behavior using limits. The left side. As you go to the left, horizontally, as you go to the left, x gets smaller and smaller and smaller, so x is approaching negative infinity. And our graph either goes up to a positive infinity or down to negative infinity in terms of the height, and in this particular problem it is going downward. So our height, f of x, is going downward. So here is our left end behavior written using a limit. We have the limit as x approaches negative infinity of f of x equals negative infinity. As you go to the left, the graph goes down. And how I know that that's true is because we had an odd exponent. The right side. Over on the right side, we are going upward. When you go over to the right, these x's keep getting bigger and bigger and bigger. The further to the right you go, the bigger x gets. So x is approaching positive infinity. So for our limit, if you're going to the right, x is approaching positive infinity for polynomials. And then our graph is either going to go up or down when we go over to the right far enough. And this one, we know the graph goes upward. So our y values keep getting bigger also. The y values keep getting bigger and bigger and bigger and bigger as you go up the graph, and they go up for forever. So f of x, our y values, the height of our graph, goes up for forever. And how I know that that is true is because the coefficient is positive in our leading term. Again, the work you would need to show are these two limits with a brief explanation. You can use some symbols and math words and phrases, that's totally fine. Or you can write it out in sentences, not a big deal. So there's letter B. For letter C, we'll take another quick look at another one of those with a little bit different leading term this time. For letter B, let's take a look at f of x is equal to negative 2x to the fifth minus 1. So again, our directions are to describe the end behavior using limits. You're going to be able to do that if you know what the leading term test, and we are supposed to explain how we know what the right and the left sides are doing. I'm going to sketch a graph, and I'm going to do that by looking at the lead term. Again, the lead term is often this first term. It is if our equation's in standard form, and in this one it is. We don't have any parentheses, and the highest power of x is here in the first term. So we are looking at a negative 2x to the fifth for our leading term this time. You start with the right side. The right side of your graph is going to go up or down, and you look at the lead number, the leading coefficient, to do that. It's a negative 2 this time, and because it's negative, I know the right side of our graph is going to go downward. So because our lead coefficient is negative, COEF is what that says, because it is negative, I know the right side goes down. The left side is either going to match that and also go down, or it's going to be the opposite and it's going to go up. And I need to look at our leading term's exponent to determine that. The exponent here is 5, which is an odd number, and odd graphs go opposite directions. So since the right side goes downward, I know that the left side has to go upward. And again, how I know that is because we have an odd exponent. Once you have this idea in your head, you wouldn't have to show that graph. But once you have it in your head and you can kind of visualize that, then you can look at what the right and the left sides are doing. For your left and your right sides for polynomials, your left side, x is always going to approach negative infinity. Right side's always going to approach positive infinity. And then you have to say what's happening with the height of our graph, what f of x is equal to. And it's either going to be going upward or downward. So f of x, after this equal sign, is either going to be positive or negative infinity each time for these problems dealing with polynomials. The left side is going upward, so that's going to go to positive infinity. And the reason I know it was doing that is because we had an odd exponent, so it was the opposite of the right. The right side of our graph is going downward, so those y values keep getting smaller and smaller and smaller, so it's going to negative infinity. And how I knew that was true was because our coefficient was negative. One more of those. For letter C, we are going to take a look at f of x is equal to x times 3x plus 4 times x minus 1. Well, this problem has parentheses, so I can't just look at that and determine what the even power is, or what the lead coefficient is. What I need to do is I need to multiply those out. You can multiply those in any order you want. Each one of those multiplications you can do in any order. We have three things being multiplied together. There are two multiplications that are here. And with those two multiplications, I'm going to do this one first. So we have x times 3x plus 4 times x minus 1. You can multiply them in any order. If I were doing this problem, I would multiply those out first. And then at the end, after I do this step, then I'll distribute the f in. So I'm going to go through and I'm going to FOIL those two sets of parentheses together so that we can finally, eventually, get rid of all the parentheses and then see what our leading term is. So we have the x in the front. I just copied that down, and now I'm going to FOIL this together. 3x squared times x, or sorry, 3x times x is 3x squared. 3x times negative 1 is a negative 3x. 4 times x is a positive 4x, and 4 times negative 1 is negative 4. In the middle there, we do have some like terms. Negative 3x plus 4x, we can add those together. So I'm going to combine those together. Negative 3x plus 4x is a positive 1x, So I'm just going to put a plus x there in the middle and combine those together. Now I have x times this trinomial, so I will be able to do my distributive property and multiply all of those in. So we have f of x is equal to 3x cubed. X times x is x squared. X times negative 4 is negative 4x. And now we have an equation that looks like the start of all the rest of those problems that we've been working on. Most importantly, I now can see what the leading term is. I've written this in standard form. Highest power of x is here. It's my first term. We have a 3x to the third. X to the third, that is our highest power of x. So the 3x to the third, that is our leading term. Let me erase a little bit. I'm just going to erase my work for a second. And I'm going to go back up here and copy our final result up here. That'll give me a little more room to work. So after we multiplied everything out for this example, we ended up with f of x is equal to 3x cubed plus x squared minus 4x. Leading term is the term with the highest power of x. So our leading term this time is a 3x to the third. From there I can visualize or maybe sketch a quick graph. Looking at our leading term, I have to do the right side of our graph first. I see that there is a positive number to start out with. It's a positive 3. If it's positive for your lead coefficient, then the right side goes up. So the coefficient this time was positive, so I know the right side goes up. The left side can be determined. It either matches or does the opposite of the right side. And we have an odd power here for our exponent, so I know the right and the left sides have to go opposite directions. The right side we decided was going to be going upward, and the opposite of that would be downward. So the left side goes downward, and the reason that I know that is because we have an odd exponent. Once I diagnose our equation using the leading term test, then I'm ready to write down the end behavior using limits. The left side, when you go to the left, your x's are getting smaller and smaller and smaller, so x is approaching negative infinity. And in this particular problem, our graph is going downward, so the y values keep getting smaller and smaller and smaller. So y is going to equal a negative infinity. And again, how I know that that was true is because it had to be the opposite direction of the right side. And that was because our exponent was odd. The other side, the right side, we have the limit as x approaches positive infinity. Again, as you go to the right, x's keep getting bigger and bigger and bigger. So if you're looking at the right end behavior, x would be approaching positive infinity. And what our graph does, it either goes up or down, and for this one, it goes up. Your y values, if you're going upward, those y values keep getting bigger and bigger and bigger also, which means they'd be going to positive infinity. The reason I knew the right side was going upward was because we had a positive coefficient. So again, as you go through and take a look at these, when you're going to use your end behavior to describe the left and the right sides using limits, you want to have your limit notation here. And then you also need to explain using the even term or the leading term test. And you know what the right side does based on the coefficient. If it's positive, the right side goes up. If it's negative, it would go downward. And then you figure out the left side afterwards. And with the left side, you look at the exponent. And if the exponent's even, then the left has to match the right. Whatever the right does, so does the left. And if it is an odd number like it was here, then the right and the left sides have to go opposite directions.